Hi folks, this time we are going to do three simple, oops, I lost my ink. We're going to do three simple F equals MA math problems. So here goes. Here's the first one. The engine of a small car is pulled forward with a force of 6,000 newtons. There's a friction force of 2,000 newtons acting backwards on the automobile, caused by a combination of the road and the air friction. If the car has a mass of 10-20 kilograms, I forgot a zero there, 10-20 kilograms, at what rate is the car accelerated? When you attack one of these problems, as we have done many times before, you start out drawing a sketch. So here's my automobile, and we're going to draw all the forces acting on the car. So here's my little tailpipe. There is a force forward caused by the engine of 6,000 newtons. That's my force applied. There is frictional forces of 2,000 newtons backwards. The mass of the car is 10-20 kilograms, and I want to know at what rate is the car accelerated. Now, before we do anything else, let's stop and do any other forces that act on the car. There's going to be a force of gravity down, and there's going to be a normal force up. And if the car is on the road and not falling through it, these two forces will be equal. So I care about the acceleration forward in this automobile. If I asked you, what is the net force? What is the net force acting on this car? Yeah, it's 4,000 newtons. Now you can do that in your head because these numbers are simple and it's a pretty simple problem. But how did we get that? So here's what happened. Here's what you actually did very quickly in your head. You said force applied minus friction force is what makes the mass accelerate. Because remember, it is the net force that makes the mass accelerate. Now, why did you subtract the friction force off of the force applied? Because of the fact that these are in opposite directions. So I am going to call forward positive. I'm going to call backwards negative. So force applied minus friction force is going to make my mass accelerate. So 6,000 newtons minus 2,000 newtons is going to make my mass of 10-20 kilograms accelerate. The net force is 4,000 newtons divided by 10-20 kilograms is going to give me a rate of acceleration of 3.9 meters per second squared. Not too bad? All right, let's go do another one of these. Woo, where did it go? It's right here. Okay. And if you're feeling confident, try this one on your own, and then let's do it later together. Just got to get it in the screen. Here we go. A small fishing boat is motoring across the lake. The motor is applying a force of 2,500 newtons forward on the boat. The combined frictional forces on the boat are 2,350. If the boat experiences a rate of acceleration of 1.2 meters per second squared, what's the mass of the boat? All right, hit pause, try it. And here goes nothing. Here's my little boat, and it's going to have a little motor on it. And we're going through the water. Here's my little fisherman out having a grand day. The motor is pushing it forward with 2,500 newtons. There are combined frictional forces of 2,350 newtons. The boat is accelerating forward at 1.2 meters per second squared. I want to know what is the mass of the boat. It is the net, or the unbalanced force, that is going to make the mass accelerate. So one more time, I'm going to call forward positive, backwards negative, 2,500 newtons minus 2,350, and yes, I know you probably did that in your head, but I want to make sure you are set for when the problems get trickier, and they will. Okay, acceleration times mass. So 2,500 minus 2,350 is 150 newtons. Divided by 1.2 meters per second squared is going to give me the mass of the boat, which is 125 kilograms, which is right around 275 pounds. If you got a light boat and a light human, that will work. All right, if you are feeling confident, try this one. A model rocket can achieve a thrust of 400 newtons upward. In order for the rocket to achieve a rate of acceleration of 2.2 meters per second squared, what's the maximum mass of the rocket? And I really would like people to try these problems because that's the only way you learn how to do physics problems is by doing physics problems. So here's a rocket, and this rocket is in flight, which may not be obvious from the way it's worded. The engine can achieve a thrust of 400 newtons upward. So this is the force up, and I'm going to call that the force of the engine. So I can just identify it, and that's 400 newtons. Now, what other forces are acting on my rocket? Well, it also has a force of gravity. The force of gravity we don't know, but we do know it's going to be equal to mass times acceleration of gravity. And the rocket can accelerate upward at 2.2 meters per second squared. I'm going to call up positive, I'm going to call down negative, and this rocket is in mid-flight. It is not sitting on the ground, so there is no normal force. There is not a normal force on this rocket. You have to have the supporting force of a surface in order to have normal. So, force of the engine minus force of gravity, why is it minus? Because it's in the opposite direction, is going to make my mass accelerate. Now, I want to know the mass of my rocket. But force of gravity is mass times acceleration of gravity. So here's what I'm going to do. The force of the engine is 400 newtons. I'm going to replace force of gravity with mass times acceleration of gravity, and that's going to make my mass accelerate. Put some numbers in here. 400 newtons minus mass times 9.8 meters per second squared equals my unknown mass times my, what was the rate of acceleration of my rocket? I got to scooch it up a little bit, 2.2 meters per second squared. Now, in order to solve for mass, I've got to get them both on the same side of the paper, of the equal sign. So here's what I'm going to do. I'm going to add mass times 9.8 meters per second squared to both sides. You do something on one side of an equation, you can do it on the other side. Those are going to cancel. 400 newtons is going to equal mass times 2.2 meters per second squared plus mass times 9.8 meters per second squared. In order to solve for mass, I have got to isolate that term. So mass times 2.2 plus 9.8 is going to equal my 400 newtons. Or, now if I add 2.2 and 9.8 together, I get 12.1. I'm going to double check with my calculator because I don't want to lie to you. Plus 9.8, 12, 2.2 is 12. So this is going to be mass times 12.0 meters per second squared is 400 newtons. Or mass is going to be 400 newtons divided by 12 meters per second squared, which is going to be equal to 400 divided by 12, 33.3 kilograms is going to be the mass. Now let's take a look at the units here because we haven't actually done the units in this direction. Newtons divided by meters per second. A newton is a kilogram meter per second squared divided by meters per second squared. So that's the same as kilogram meters per second squared times second squared over meters. Second squared cancel, meters cancel. You end up with kilograms, which is what we want. Life is good. All right, see you next time. Bye.